In this example, we are going to be focusing on roots. We're going to do 4 different examples. So let's go ahead. You'll also find these in your workbook. All right, so what is going on over here? We need to know our square root laws, but we'll talk about that as we go with every single example. Currently, everything under that square root is being multiplied. So that means that we can go get the square root of each of those separately, meaning we can go get the square root of 36. We can go get the square root of x to the power of 4, and we can get the square root of y to the power of 6. When we do that, the square root of 36 would be 6. The square root of x to the power of 4 would be x squared, or x to the power of 2. And then the square root of y to the power of 6 will be y to the power of 3. Now let's just go into that in a little bit more detail. If you got that and you're fine with this, move on to the next one. But for the rest of you, let's just talk about that quickly. So according to our square root laws, when everything is being multiplied, yes, we can get the square roots separately. And I'll emphasize when it's not like that in one of the later examples. But okay, let's just look at this idea. Well, we know, what does the square root mean? The square root means which number times by itself will give me that. All right, so we know that. We use our calculators for this. You've been dealing with this for a while. Okay, then the square root of x to the power of 4. Now, we've got x to the power of 4. Our 4 is in the exponent, so that doesn't need to be a perfect square in order for us to get the square root of it, because the same idea holds. What number times itself will give me x to the power of 4? And that will be the square root. So let's think about that. It will have to be a base of x. And remember, how does it work? Your laws of exponents. When our bases are the same and we are multiplying, we will add our exponent. But these will be identical, right? I can't put in there a 3 and a 1 because they're not the same. So it will be 2 and 2, because 2 plus 2 will give me 4. So that's why the square root for x to the power of 4 will be x to the power of 2. Then let's look at the square root of y to the power of 6. 6 is in the exponent. So a lot of students would say that, no, you can't do that because 6 is not a perfect square, so we can't get a square root of it. But 6 is not a base in this case. It is part of the exponent. So same thinking. We've got a number times itself that is equal to y to the power of 6, and that would be the square root of it. The base will have to be a y, because how else are we going to get to that y there? And then we need to figure out what those exponents must be so that when we add them, they get us to 6, because remember your laws of exponents. When my bases are the same and I'm multiplying, I add my exponents. And that's why it will be 3. And that's how we get to that answer over there. So just to kind of summarize that for us, let's call it a shortcut, if you will. If you get the square root of y to the power of 12, the 12 is the exponent, it's not a base, so it doesn't have to be a perfect square. It just needs to be divisible by 2. So square root of that will be y equal to the power of 6, because y to the power of 6 times y to the power of 6 will give me y to the power of 12. So shortcut, to get the square root, my exponent needs to be divisible by 2, and that will be the square root. Okay, so there's our final answer. Let's move on to the next one. For B, we are dealing with a fraction. That's okay. We still just have one term. At the top, we've got one term. Everything is being multiplied and it's being divided. So we can get the square root of each of those separately. We can get the square root of x to the power of 4. We can get the square root of y to the power of negative 8. And we can get the square root of 81. They are all square rootable. Let's say it like that. So what is the square root of y to the power of 4? It will be, x to the power of 4. It will be x squared. what is the square root of y to the power of -8? And we're going to do that in two different ways. Let me create a bit of space there. That will give us y to the power of -4. I'm just dividing that one by 2. And then the square root of 81 is 9. Our final answer there would be x squared over 9. And I'm making that exponent positive, moving it down. There's our final answer. How could we also have looked at this? Well, from there, maybe your instinct was to write the y with a positive exponent like that. And then from there, you would have gotten the square root. So the square root of x to the power of 4 would be x squared. That would be 9, and that would be 4. We're dividing it by 2. Note that we get the same answers. So both work. Next up. Now with number C, we've got a little bit of work that we need to do first before we can apply and use that square root. So we keep the square root. We only remove the square root once we're actually getting the square root of the numbers inside the square root or under the square root. But for this one over here, I need to keep this for a bit because there's some work that we need to do under the square root. So if we think about what we've got over there in the numerator, and it is raised to the power of 4. I'm just going to write it over here. Okay, all the exponents on the inside must get multiplied with the exponents on the outside. We're never going to multiply an exponent and a base. So that will give us a -2 to the power of 4. I'm keeping that in a bracket because it is a negative number so that I don't mess that up. And then it will become a to the power of 4 and then b to the power of 8. And then if I get a -2 to the power of 4, that should give me a positive 16. And you can check on me using your calculator or your brain, whatever, but I think that's all right. Okay, so we simplified the numerator to that. I'm keeping the square root because what we did was simplifying the top, not getting the square root of the top, right? Now for the denominator, we've got the -b squared that is raised to the power of 2. Okay, so what is that going to be? I'm going to expand that a little bit. It's going to be -b squared that is being multiplied by itself. And that is going to give me a b to the power of 4 because it's a negative times negative. There's like an imaginary 1 in front, for that coefficient. Okay, is that it? Yeah. So we've got a b to the power of 4 there. Okay, perfect. Now we can get the square root. And we can get the square root of all of those separately. The square root of our 16 would be 4. The square root of y to the power of 4 would be, why am I saying y to the power of 4? A to the power of 4 would be a squared, and then b would be to the power of 4, because we just half that, right? Because b to the power of 4 times b to the power of 4 would give you b to the power of 8. And then for the denominator, that gives us b squared. Now, because we've got some bases over here that are the same, we can simplify that one step further. So it would be 4a squared, and then b to the power of 4 minus 2 would be 2. And there would be our final answer. Now, could we have done this? Let me just create a bit of space. So from that step over there, under the square root, let's say your kind of thinking was to simplify it there already by saying it will become 16a to the power of 4, b to the power of 4, because you simplified those two underneath the square root already. Perfectly fine. Then we're going to get 4a squared, b squared, and note that it is exactly the same answer. So all good. Your working out doesn't have to be a duplicate of somebody else's work necessarily, just as long as you do mathematically some things. Okay, last one. Now, grade 9s, note with this one over here that we have got that plus in between. I see students do this all the time, where their instinct is to say, well, that is a perfect square and that is a perfect square. So this answer would be 4x plus 3x, and then I guess they would put it together and say that that is equal to 7x. But according to our square root laws, and we can test this as well, when we've got two terms underneath the square root, we can't break it up and get the square root of the one and the square root of the other. We need to simplify what is underneath the square root. So they are like terms. We've got our x squared and our x squared, so we can put them together, right? So 16x squared plus 9x squared would give us 25x squared. So we're simplifying what is underneath the square root. And now we've got one term underneath the square root. So that will give us 5x, and there would be our final answer. Do you see that gives us a completely different answer? And so make sure if this is something strange for you, recap your square root laws.